Section 7.2, inverses and relations of functions. So our targets for today, let's take a look at what we're going to be able to do after the lesson, is graphing. I can graph and recognize inverses of relations and functions, and I can find inverses of functions. All right? Pretty much this section is a tie-in for us. It's going to take us from exponentials, which we looked at yesterday, and it is going to bridge the gap between this and logarithms. So what you're going to see is that we are going to talk a little bit here today about some linear functions and find out how to get the inverses of those, so that when we start talking about the logs, it's going to make a little bit more sense, because guess what? Exponential functions, logarithms, they undo one another. So that's why we have this lesson that's going to fly in between today. So let's take a look below. It's actually going to be pretty straightforward, pretty easy for most, I think, because of our friends' linear functions. So let's read about what is going on here at the bottom. So skip the warm-up. Don't worry about that for now. Let's talk. A relation, hopefully as you remember, is a set of ordered pairs. A function is a relation in which each x value has at most one y value paired with it. Remember, graphically, think of the vertical line test. 2 is poo. To graph the inverse relation, you can reflect each point across the line y equals x. So there's a bit of symmetry going on there. This is equivalent to switching, underline that right there. Oh, I almost fell asleep, sorry. Switching the x and y values in each ordered pair. Yep, that's today's lesson right there. To get the inverse, you basically exchange the domain and the range, the x and the y, the input and the output. So let's take a look at how we can accomplish that first target. Let's graph the relation, connect the points, then graph the inverse. So this is our relation that we have here. In this case, is this relation a function? Well, it actually is, because you have that unique x going to just one y. Let's get those things plotted. Watch your scale here. So 0, 2, we're going to put our dot there. 0, 2, over 1 up 5. Then we're going to go over 5 up 6. Are you doing this? I hope so. Stay awake with me. Stay with me. And then you're going to go over 8 and up 9. Hashtag, you got that, obs? That's what I thought, girl. Dot right there. It does say to connect the points, so we will do so. Connect the dots. La, 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 la. There we go. Let's use a little bit of St. Clair red for the inverse. So how do you get the inverse then? Well, you literally exchange the x's with the y's. We can rewrite this in a table if you'd like, or you can work just kind of backwards. I'm going to quickly just rewrite in a table. So my x's now become the 2, the 5, the 6, and the 9. My y's become the corresponding 0, 1, 5, and 8. So there is the table of my inverse relation. Okay? We'll talk about the domain and the range in just a moment of both of these. So get those graphed. Okay, 2, 0, 5, 1, dot there. Are you having fun yet? Because I am. I love graphing. These are so pretty too. I wish we studied fractals. Those are prettier. And then over 9 and up 8. Did I get it? Hot diggity, I think I did. Let's connect those. And notice across the line, y, and I'll put that in some fun light green. Across the line y equal x, we have a lot of symmetry going on here, right? If you folded that down the middle, the relation would match up perfectly with the inverse that you have. For the domain and range, let's get some set builder notation going, because we're rock stars like that. We could actually, since we connected the dots, we want to make sure we include those values. That's why I said set builder, not just roster. So we'd have, remember, the set of x, because it's x's for domain, is going to be between 0 and 8, since we were instructed to connect those dots. The range for the relation then, going to be similar. Look up and down though. So it's going to be y, since you just looked up or down. And then we'll have between 2 and 9. Ooh, what fun! Now, for your inverse, guess what? You literally just need to, and notice how I changed the color to try and help, switch these two to get the domain and the range. Now, one thing you have to be careful of when you switch them is, I'll leave it at red, you need to make sure to change to the appropriate letters. So like the range of the relation becomes the domain of the inverse. I don't write y though, I write x. And then it'll be between 2 less than or equal to x less than or equal to 9. And then we'll go with the range action here. We'll do a little friendly y, and that would be 0 less than or equal to y less than or equal to 8. Okay, there you go. We're bringing sexy back, mathematically speaking. I love it. So that's our first target. So graphing and recognizing the inverses of relations and functions. Okay? Any questions? I'm not there to answer them. Suckers! Seriously, I'm really not there right now. So you're just going to have to kind of deal with it. Uh-oh, the spinny wheel of death. It's gone. All right, let's take a look at our second target. The computer's not happy about running it this time. That's okay. Ooh, function notation's back. Oh, I hope you remember this from section 1.7. A little bit of function notation, the inverse, yeah. This is not the reciprocal, yeah, but rather the inverse. So we're going to have to use this proper notation, of course, or you're going to lose points on your quiz. Suckers, just playing. All right, use inverse operations to write the inverse of f of x equal x minus 1/2. F of x, I think there was a letter that we used for f of x before. It's the function of x, so it's the output. Oh yeah, we can write that as y. Okay, now I've done nothing yet to get the inverse. You ready? I'm going to be consistent with my colors. Just like when you graphed it, you switch the domain and the range. Here, you just switch the x and the y and resolve. That's all you have to do. That's it. In order to obtain the relation. Remember this, because right now we're doing lines. When we get into exponentials and logarithms, the math is going to get harder. The concept of inverse, though, fortunately does not. So we switched these two. So we're now going to solve for y. Since we switched them, I'm going to put a little prime here to indicate that I did change that in some way. In order to solve for y prime, you just need to add 1/2 to both sides. Hot diggity. And you're done. Or are you? That's right. You better tell me you're not quite done. Because really, you have to use that proper notation. So we have f to the negative first, indicating the inverse function of f is equal to x plus 1/2. Will it always be that easy? No, not if you're multiplying. You'd have to kick it up just a wee bit, and we'll do that on the next page. Okay? Oh, you better not be yawning. No yawning. Who could be yawning right now? Oh, maybe Cooper. Cooper might be yawning. I'm just playing Cooper. You're better than that. Okay, flip the page. 2D. We're skipping 2B or not to be. Go to 2D. Same directions. Let's just change it up ever so slightly. Is we are going to take a look at using inverse operations to write the inverse of this function. Okay, once again, same idea. What is f of x equivalent to? Y, because, oh gosh, I'm so funny. Oh, I'm so sad. Just kidding. Distribute the 3. Why? Because it's just easier to work with, seriously. Notice I'm still in the blue, because I have yet to address the inverse piece. Now I shall do so. Switch those two. Boom goes the dynamite. So let's pull it up here. You would have then x equals 3. I'm going to put a y prime just to indicate, that's a horrible prime, just to indicate that I've changed that. So I'm now working with the inverse. And now I'm going to resolve. So in this case, I would end up adding the 7. Oh, no. Did anyone catch it? Did you yell at me yet? Why? Did you see it? I'm just going to erase. What's he erasing? What'd he do? Did you catch it? I know Hannah Wilding's yelling at me right now. 21. E! Okay, we fixed it. Watch that distribution. Sorry. See, even the grade fun for makes mistakes. I'm just kidding. You know I make mistakes all the time, but I always fix them. All right, back at it. Add 21 over. Sorry about that, yo. So you get x plus. See, you're not going to make that mistake ever now, right? You're never going to forget about the distributive property. Taste the rainbow. Good, I'm glad. Divide by 3. Divide by 3. Remember, everything, both terms are divided by 3. So you would have 1/3 x plus 7 equals, I'm just going to jump right to it because you're rock stars. You're honors kids. I can handle that. And there's your value. Okay? There's your inverse equation. Once again, symmetrical across the line, y equals x. All right, last part, just a little real-world situation for you to check out, and then I'm going to be quiet. You can work on your homework. Don't forget, switch the variables because they are named for specific quantities in the real-world problem. Thank you, Mrs. Watt. I appreciate that. 5A, Juan buys a CD for 20% off the list price. He has to pay $2.50 for shipping. The total charge is $13.70. What is the list price of the CD? Okay. 20% off. What are you really paying? What are you really paying? You're paying 80% is what you pay, right? 80%. Keep that in mind, and then this shouldn't be a shock. Equation that we can form. I bet you see it. 0.8 times L plus 250. Okay, because the 250 is the additional shipping, and then we will substitute in a moment for the total charge. Just be patient for me. Watch how I'm going to use the inverse operations. Okay, are you ready? Are you excited? So, I hope you are. Let's get and move things around a little bit. Solve for the new variable. And this, I'm not going to lie, folks, a little silly. I just talked to Mrs. Hughes. She said, a little silly. I said, a little silly. But it's okay. You'll get the idea. Oh, that is a horrible L. It's okay. We got it fixed. Divide by 0.8. Divide by 0.8. At this point, the total charge was $13.70. So really, I'm just going to plug that in there. And a pretty trivial word problem at best. Loving it. Are you loving it? Because I am. I'll let you put it in your calculator. Oh, wait. Got all the time in the world. No, I'm just kidding. I really want to go home. Okay, so list price is, don't forget your unit, $14. Nice. All right, there's our targets. Nothing too bad. I told you today was going to be a breather. Don't worry, we'll get super intense the rest of Chapter 7. So I can graph and recognize inverses of relations and functions. Nailed it. And I can find inverses of functions. Get on my level. Deal with me. So for the remainder of class, do yourselves a favor. Don't do that. But rather, take a look then at your homework, which, if I'm not mistaken, is on page 501. That's up in front of you right now. So if you would like to freeze the screen, you can certainly take a look. And of course, get your textbooks up on your phone. There's a couple in the back. Or if you need to use a laptop, you may certainly do so. Thanks. Miss y'all. Hope you had a great time. Peace now.